Hello, hello. Welcome to Unit 2. So our next unit for geometry is about transformations and congruence. And today we're going to do a very quick introductory vocabulary lesson here on what you are about to experience. So without further ado, here we go. Okay, so what is a transformation? A transformation of f, a transformation f of the plane is a function that assigns each point P of the plane to a unique point f of P on the plane. Okay, why do mathematicians make everything seem so hard? What we're trying to really show you here is it's like a function that you had in algebra. Remember when you had f of x in algebra and it took x and it did something to it? That's what transformations do to shapes. So if I take a function, a transformation kind of function of the plane, I'm going to transform the plane into something else. So we have an input, which is the plane, or an object on the plane, a line, a point, a shape, all kinds of things, and then we do something to it. We move it in some way, okay? So a transformation in function notation looks like that. Now, what is that really going to look like? It's really going to look like this. We're going to take something that we call the pre-image, which is a figure before a transformation. We take the pre-image, which would be like ABC right here, and then we do something to it. We maybe move it over to here, and that gets us this guy, which is called the image, and that's a figure after the transformation. So before pre-image, after image. What happens in between? The transformation does. So I transform ABC into A prime, B prime, C prime. That's called prime, by the way, to know that we changed it. And then once we change it, that's what we call it. Now, what is distance preserving? Well, that's exactly what you think. Distance, meaning the lengths of things, are preserved. The lengths stay the same. So the lengths of the side of the pre-image are the same as the lengths of the sides in the image. So something that is distance preserving maintains all the lengths. All segments stay the same length. Angle preserving, it's exactly what you think it is. The angles in the pre-image are the same as the angles in the image. Well, what if something stays the same all around? All the angles stay the same, all the sides stay the same. Basically, this thing is still the same size as when we started. That's what's called a rigid transformation, which sometimes we'll call an isometry. So these two things we need you to merge in your brain. Rigid transformation and isometry mean the same thing. A rigid transformation is a transformation that preserves both distance and angle measure. Oops. This and is supposed to be here. So if both those things are preserved, it's called a rigid transformation or an isometry. Okay, so now what can we do with all this? I'm going to actually open up my smart notebook right now, and I'm going to show you some of the transformations that we are going to look at. There we go. I should sing a song. No, you don't want me to sing a song. I have corny jokes already. All right, so let's see. If I am going to do this here, let's take this and I'm going to widen our window here. I am going to take a shape. I am going to take, here we go, a nice little pentagon. If I take this pentagon, okay, I am going to do this. And if I move it this way, so if I just move it, okay, slide it back and forth, I'm not turning it, I'm not making it bigger, I'm not flipping it over anything. If I just move it around, what I just did is called a translation. A translation is a slide in a certain direction. So that's one type of transformation that we're going to talk about. Another type is if I were to take this guy, all right, I'm going to bring it out here just so I can reuse it here. If I were to take that guy and I was going to turn it, okay, see how I can turn that? This is exactly what you think it would be. This would be a rotation, okay? Now, a rotation is, again, exactly what you think. But here's the new thing about rotations you need to know. You can rotate something about the center of the shape, just like I've been doing here, okay? There's a rotation about the center of the shape, but you don't have to just rotate it about the center. I can take a rotation and I can say turn this guy around this point. Now this is really hard for me to show on the smartboard, but basically it's going to turn around this point. So it's going to kind of like come up here, but turn a little. So if you look, this bottom piece, this flat piece turned around the point to make this new rotation. So all I'm getting at here is when you get to rotations in a couple of days, when we talk about turning, it doesn't have to turn about the center. It can turn about an external point. It can also turn about a point on the pentagon. There's a lot of different ways it can turn. If it was going to turn about a point on the pentagon, it might look like this, where I turn it about itself. So I take this guy, okay, and I turn it, let's say, this way, but it ends up like down here. I've turned it along itself to end up somewhere else. So this line right here turned down to there. Again, it's very hard to do on the smartboard, but you think about turns in different ways, okay? I've been rambling about it for a couple minutes now. So we've done translation, we've done rotation, and then the only other thing we've got is a reflection. So if I take this guy, here I'll put it here, and I do a flip, oh my lights just turned off, that's kind of cool. If I do a flip up down, there's a reflection. This guy flipped down here. So a reflection has a line that it flips over, and then it can flip down. It can flip over horizontal lines, vertical lines, slanty lines, but a reflection is where you flip over a line. And sometimes we will do that through a point. Okay, so I'm going to stop talking now because I've been rambling about these things for a while, but basically here's what you need to know. Transformations change objects. They take a pre-image, which is your input, and give you back an image, which is your output. And that's kind of like a function notation kind of thing. In the three major transformations, we're going to start talking about are rigid transformations. Those are ones that preserve angle and distance. And those rigid transformations that we're going to talk about are translations, rotations, and reflections. All right, so we need a joke. The joke today is going to be about me because I tripped this morning. So what is a klutz's favorite season? If somebody's a klutz, what's their favorite season? Fall. I'm done. So have a great day, evening, morning, whatever it happens to be, and we will see you in geometry class. Bye.